Yeah, hello guys. This time I would like to show you my newest motor controller boards, which you can see right in front of you. It has small heat sinks made out of aluminum strips, and the blue connectors are for the motors, and the pinhead on the right side of them is for the input signal, which is 5 volt, and here on the top is the input for the power supply, which is 12 volt DC, and this is the back side of it. And as you can see here there is a small control circuit for the bigger MOSFETs. The bigger MOSFETs can be seen here. This one is always the P channel MOSFET, and right next to it is the N channel MOSFET, and so on, of course. And here we have the green LED is for the left input, and the yellow LED is for the right input, and the red LED is on when both inputs are on, and so this would be the worst case, but the circuit on the back prevents the circuit from damage. Yeah. That's the second one. It's exactly the same. Some fuses on the back side of it, and some capacitors, and here on top is the blue LED, which indicates that the circuit board is switched on. And yeah, and here always on top of the board there is a 12 volt supply for a fan or some other circuits. Now let's test it a bit. Let's switch it on. Yeah, and the blue LEDs are indicating that the board is switched on. The thing vibrates a bit, so I get some Croco cable underneath it, and here we have a small motor. Let's put it in here. That looks good. And here we have a small microcontroller, which I connected the 5 volt output to the green cable and then the white cable, and we put it on the right input, and now the motor is on. Looks very good. And the yellow LED should be turned on, but it's very dark, of course, because the resistor for each LED is about 10 kilo ohm. The reason for this is that the Arduinos or microcontrollers don't have that much output current, and so it is only visible if I turn off the light, which I do. Unfortunately, it cannot be seen on the camera. Yeah, but just believe me, it is there, but not very bright. And let me just switch on the light again. And now the other input, which is right next to it, and now it rotates in the other direction. So, and that's all the magic which is possible. And now the circuit protector. And now the circuit protector works like this. If I connect both inputs with this screwdriver, so 5 volt is on both pins, so the LED, the red LED should be turned on, which can hardly be seen. Okay, I really need to change the resistors for the red LED, and nothing happens. So otherwise now when I connect both inputs to 5 volt, there should be a really big short circuit through the whole system, which eliminates all copper paths. Okay. And on my circuit there is nothing, which is very good. Okay. Yeah, now let's test a bigger motor. Let me just switch off the power supply so it is not that loud. Okay, so small motor, get my big coil of copper wire, and the resistance is about 1 ohm, which means that at 12 volts the current is about 12 amps, which is way too much for my power supply because the current limit is 10 amps. We will see what happens. Let me just disconnect at the input 5 volts from the microcontroller, and now we power on our motor, our H-bridge or motor driver, and now we will print in. It looks very good. It has about 10 amps at 14 volts. Oh, and it's already kind of warm. Jesus. And yeah, as you can see, the coils are moving around when I switch it on just a little bit, and the fan voltage drops. That's on, and the power supply says 10 amps at 14 volt. It's very. Let's see if I can measure the temperature. Yeah, let's measure the temperature inside of it. Now it is already getting cold again. Yeah, let's just wait a second for the temperature to stabilize itself. Okay, now it's stable. Now let's switch it on. And there it goes. Yeah. I already can feel it here. It's very good if it's cold or something. It's not. I'm not burning my fingers. Now it's too hot for the fingers again. So yeah, and it already smells. It smells like some hot wires, of course, obviously. And you can already feel the heat, the heated air, which is moving up into my face. Let's switch it off and measure the MOSFET. That's the warm one. It is not that warm. Okay, some kind of 40 degrees Celsius. That's not very warm. But let's give it more to work. Unfortunately, the fan rotates less, and so the cooling is less, but I will fix that in a later version of it. You can see here the MOSFET temperature slowly rises, and it should be touchable at 40 degrees. And I'm measuring with the N-channel MOSFET, and the P-channel MOSFET should be warmer. I cannot really measure it, so yeah. The coil is still very hot, so let's unplug it. And let's put it somewhere else. Somewhere else on the table, of course. Let's switch it off and give it away. And now let's try a bigger motor, of course. As you can see, the cables are much thicker. Let's see the behind if there's a damage somewhere, or if something is hot. No, everything feels really good. And yeah, so we have a go for the bigger motor, if it is possible to plug it in somehow. Yeah, that looks great. Yeah. Put everything in the screen area. thanks for watching and see you next time.